All right, my friends, video part 2. So the final part of the notes that I wanted you guys to review was this idea of coterminal angles. And then there's some really great practice problems that you can look at the key to figure out, or just kind of make sure that you check with the key. But as always, you can always reach out and ask questions at any time about any of this material. You'll also get a good opportunity to practice it when you guys do the Delta Math assignment. So with the idea of coterminal angles are angles that have the same initial and terminal, makes sense, coterminal sides. So what you guys are going to see is that if I ask you to find a coterminal angle, it basically has to start and end in the same place. But keep in mind, you can go around many more times, but still land in the same place. You can go around the opposite direction and still land in the same place. So there's different ways that you can make this happen. But one example is if I gave you an angle, let's just do something super simple. If I said graph 90 degrees, you would graph an angle that looks like this, 90 degrees. But I can also say graph negative 270 degrees. And you would have that same initial side, but then when you rotate, you would rotate the opposite direction. But note, you would have the same terminal side. So this idea of landing in the same exact spot doesn't matter if you rotate in opposite direction or you go around more than once. So keep in mind, I can also give you an angle measurement that's over 360. And I can give you a measurement of, what is that? 450, I believe. Let me see, 450. So if you were to do that and you were to graph 450, keep in mind, you would go start at your initial side. You would go around one full time to represent 360. And then if you go that in the original, the extra overage there, so we subtract 360 from that, and you see you have that additional 90 degrees left over, note that that would also land on the same spot. So this idea of starting and ending at the same spot, no matter how many times you go around, and no matter which direction you go around. I don't like how that looks. It looks so sloppy to me, so I'm going to get rid of this, but I think you guys get the idea. There we go. So we can see that those start and end at the same spot. So if you're asked to find coterminal, positive or negative, it could be in radians or degrees. So keep in mind that if I wanted you to find something that was a positive coterminal, well, think about with 90, if I wanted to get another answer, I would just have to go around a full 360. So what you're going to see is that if it's in degrees, so if your measurement is in degrees, to find a coterminal angle, you're either going to add or subtract 360 depending on the type of angle that they want you to find. So you'll see in the delta, it'll say it has to be between 0 and 360. Well, that means they want a positive coterminal angle. So in the case of this one right here, if I said for part A, find a positive coterminal angle, we could take 60, and to find the positive, we would take 60 and add 360. And that would give us 420 degrees. To find the negative, you would do 60 and subtract 360. Because basically, think about, you're at 60 degrees, but now you're rotating the opposite direction 360 degrees. You're going to land right back where you started, and you would see negative 300 degrees. So you start and end at the same spot. So if I said right now, graph 60, graph 420, graph negative 300, they're all going to be same initial, same terminal side to those to that angle, but you just went around a different number of times or a different direction. Okay, now we do the same thing with radians, but remember, one full time in radians is not 360 degrees, it's 2 pi. So if you're asked to do this in radians, you're going to take that angle, and instead of adding 360, subtracting 360, you're going to add 2 pi or subtract 2 pi. Now, the problem with adding 2 pi, subtracting 2 pi, is that it doesn't have a common denominator. So keep in mind that if this was written over 1, we want to think about how do we take 2 pi and break it into 6. So if I wanted to change my denominator to a 6, I would have to multiply the denominator by 6, thus multiplying the numerator by 6 as well. And then note that that is equivalent to the 2 pi, because 12 pi over 6 divides out to 2 pi. And then we can add across and get that answer in radians. Same thing here. We would use that same measurement of 12 pi over 6 because it's the same denominator. And when we subtract, that would give us an angle in radians of negative 17 pi over 6 as our answer. Okay. Now, the rest of these are just asking you about like different measurements and where the quadrant that these lie. So with these types of problems, keep in mind that when you're dealing with radians, if you don't know what this means, if you're like negative pi over 12, what? And you can't wrap your head around that, convert it to degrees. So option 1 is you could just multiply by 180 over pi, and then you can cancel that. We can get out our calculator here, and we can find what this would be equivalent to. So 180 divided by 12. And then I could see that this is equivalent to negative 15 degrees, and I can answer it that way. Or another way you can do this is you can just think about, here's my quadrants, my 4 different quadrants. And if I talk to you guys about this being 2 pi and this being pi, obviously that doesn't help us when I want to think about in terms of 12ths. So think about what each of these would be in terms of 12ths. This would really be 12 pi over 12, right? Because that equates to pi. And then this one over here would have to be 24 pi over 12. But now, by converting that so it has a common denominator, it's much easier to think about where this would fall. Because if I said negative pi over 12, well, think about if we're going in the negative direction, this would have to be 6 pi over 12, right? Because if the whole thing is 12, half of that is 6, right? So if that's the case, and I said, which quadrant is negative pi over 12 going to fall in? Well, it would have to be somewhere in quadrant 4 because I'd be rotating that negative direction. Now, we already saw it's negative 15 degrees, but if you cut the axes and you kind of think about that common denominator, like I did, you would get that answer as well. Either way you think about this, the answer for this, for the quadrant, would be quadrant 4. Now, when you see this next part, this is scary because it's like, wait, where's the pi? It says 3.5 radians. What this means is that 3.5 radians is like you've actually done the quotient, you divided. So like, for example, in part A, if I were to rewrite that in terms of radians, pi over 12, that's the exact answer. But in my calculator, if I did pi divided by 12, that decimal is what they're giving you here. So they actually took whatever it was and divided whatever pi divided by whatever, and that's giving you this answer here. Now, that can be confusing, but there's, again, 2 ways you can deal with this. Way 1 is convert it to degrees. Keep in mind the radians is absorbed in here. So if you wanted to convert this to degrees, think about this as 3.5 times. If I want to cancel the radians, it's in here. It doesn't seem like it is, but it is. I would have to put pi down here and 180 on the top. And then when I find my answer, I would have to multiply across. And I would have to get this 3.5 times 180. Oh, that's not 180. Try again. And then I would have to divide that answer by pi. And again, try to wrap your head around the fact that pi is like absorbed in here. So in a sense, it's going to cancel when I divide by pi. Even though you don't see it in here, it is going to cancel when you divide by pi at the end. So you could get that this is approximately 200.5 degrees. And then you can graph it that way to think about it. Or the other way that I think is easier is just think about what I said when it comes to the radians on here. We know that this is pi. And then if you go all the way around, this is 2 pi. And keep in mind that halfway would be pi over 2, right? If the whole thing is pi, half of that is pi over 2. So if we know that pi is 3.14, and I said, what is pi over 2? How many radians is that? Just use your calculator or take half of 3.14. You're getting that this is approximately 1.57 radians. So if I said, what is 3.5 radians? Well, it's more than pi because pi is 3.14. The question is, do I get into quadrant 4? But think about if each 90 degrees that you go, or pi over 2 radians is 1.57, this is another 1.57, this would be another 1.57. So if I add 3.14 to this, approximately, you're getting that this would be 4.71 radians, okay? Which if I ask you for this problem, where is 3.5 going to fall? Well, then it has to fall somewhere in between pi and that 4.71. So this would have to be in quadrant 3. So as always, you can think about this different ways. Whatever way makes most sense to you, you can either convert it or you can think about, what each of those radians represents. And as we do more with the unit circle, I think it'll be clear kind of what each of those radians are. Okay, so that last one, you have a decision to make. You can either, again, convert, or you can think about, what this would equate to when we think about the quadrants. I'll do it both ways just for those of you that want to see it both ways. But what we would do is we would multiply this by 180 over pi. So then the pi's cancel. And then we can multiply the 11 times 180. And then we can divide that by 4. And so what you get is 495 degrees. So you could either graph that and think about what quadrant that would land in. Or second option is you can think about, this is pi, this is 2 pi. If I want everything in terms of fourths, this would be 4 pi over 4. And then this would have to become 8 pi over 4, right? Because that should equal 2 pi. And then if I said, where's 11 pi over 4? Well, hard thing here is that, we can think of this as 0. We can think of this as 8 pi over 4 if you go one time around. But we're going to have to go more than one time around. And the question is how much more? Well, if I want to go to 11 pi over 4 and I'm at 8 pi over 4, think about that. Before that was 8 pi over 4. If this was just 0, if this whole thing is 4 pi over 4, this would have to be 2 pi over 4. Because it has to be half of that, right? Half of 4 is 2. So if I wanted to think about going from now 8 pi over 4, so one time around, and then I go to that next axis, you're going to see that every time you go up an axis, it's equating to 2 pi over 4. So notice that I would have to make it around into that second quadrant for this answer. So the answer for this would be quadrant 2. Okay. But again, if you like the degree measurement, you can also do that. Just keep in mind that you'd have to do 495 divided by 360, and that's going to tell you 135, which means we'd have to go past 90 and then somewhat into that quadrant 2, halfway through that quadrant 2, in order to get to that final angles resting spot. Okay? So that's how you go about doing this. The rest of this is for you to practice, so enjoy. Look at the key, ask me questions, reach out at any time, and I'd love to help you if you are struggling.